Well, first of all, it's an absolute pleasure to be at Stanford and among some of the brightest leaders of the next generation, or leaders in their own sense today. But my journey had three chapters: an opportunity to learn and to be able to acquire knowledge, and then a little bit of earn when it comes to expertise, experience, prove yourself, and then this is an opportunity to return. And this is why I'm coming back 20 years later to the Valley right now to talk to you guys, and hopefully over the next 20 or 30 minutes, I'm gonna be able to inspire at least a few of you to create the next big thing, because you should be very appreciative of where you are. You're talking about 140 years of really transforming humanity. I mean, the company that I worked for started from Stanford. It was a couple of folks like yourself trying to solve a communication issue. Fast forward, it has fueled the internet economy, which is today in trillions of dollars. And this ecosystem alone have created what? $2.7, $3 trillion worth of value. And I'm confident over the next couple of years, we're gonna see some unicorns, decacorns, or even trillion-dollar companies here. Going back to my journey, I started in Cisco at in San Jose in Building 10, writing codes for iOS at that time. And iOS for us back then, 20 years ago, wasn't your iPhone operating system, but it was really the operating system for how networking works. And it was really a parallel you could draw from today's time. Cisco at the time was the most valuable company in the world, close to $500 billion. If you adjust it to inflation today, it's close to $1 trillion today in today's dollars.
Right.
And we really saw similar waves. I mean, as an engineer, I'm a big fan of a ratio called signal to noise ratio. And as long as the power of the signal to you as an individual and as a leader is very clear and more powerful than all of the noise that is surrounding you, because with what history have taught me, that we live always in times of change, and the rate of change and uncertainty is gonna follow us. So I'm hoping that you can get some signals. Signal number one that I want you to really get it through is that what we're observing today in the AI world, or in the intelligent age as marketeers like to call it, we have seen it firsthand in the internet age. First, a lot of hype and excitement about hardware. And I remember we were pushing Cisco routers and switches to client bases without really realizing what was the applications or how it could diffuse across industries. And only when we had a few innovation triggers where really we shifted to the line of business, where networking was able to empower and change the way we work, live, play, and learn, telemedicine, teleeducation, GovTech, and reform bureaucracies from red tape to red carpet. This is really where the magic happens.
Right.
So the first signal that I want you to appreciate is that we're seeing this firsthand right now. There's a lot of hype about hardware, and I know that this is a hardware course, so we're gonna talk extensively about what we expect from you as the next generation to do these unlocks to transform the industry.
Well, it's a systems class, so you can feel free to go up and down the stack as you want.
Indeed, indeed. But what we have seen is that for every dollar made in hardware, there was 10 to 20 bucks being made in software and services.
Right.
And we're seeing this right now with a little bit of agentic AI mirroring back then what used to be called SaaS for B2B, how the diffusion across industries and verticals is really making the difference.
Right.
So let's talk a little bit technical. So what are some of the unclogs challenges, technical challenges that I'm expecting a Stanford graduate to work on? Number one is energy efficiency. You can appreciate, as the energy leader in the world, we power up 20% of the energy mix, but we're still looking for inefficiencies to be solved. First one, the current architecture for compute, whether CPU or even GPU, conforms to the von Neumann architecture, which is practically you have a component that does execute, and then you need to fetch from memory the data and the instruction set. This is creating a lot of inefficiency because every time you have to call memory, that's picojoules. And if you multiply it by the billions of access, that's watts. So every time you call on memory, that's a single watt. Every time you call on solid state storage, that's 10 watts. Every time you call an interconnect, that's even multiple of watts. So the first problem statement that we have to solve for is how you could, guys, engineer for us the next generation compute architecture. I'll give you some food for thought. Again, I'm expecting from Stanford over the next couple of years, we see a couple of startups in this space. First of all, the silicon architecture is outdated. The gap when it comes to the number of voltages that you could push to make sure that you can appreciate a 1 and a 0 is roughly, when you're talking about EVs, you're talking 1.1. We need to make sure that we work on compound silicon, compound semiconductors. So we need to transition from, for example, silicon to gallium nitrate because it has a bigger band and you have a big quicker. As an analogy, think of the number of transistors that you can, fabricate on a wafer. Think about the switches could be either rubber valves that they have a leaky current versus a metal valve that is able to do fast switching. So the first problem statement that we have to solve, we need a new compute architecture. 40% of the cost of GPUs and NPUs and LPUs today is in memory. High bandwidth memory is the biggest unlock, and no wonder that Stanford came up with the memory wall white paper, which articulated that if you look at the past 20 years, Moore's law, T-flops, the number of transistors have been doubling significantly in 20 years, 60,000 times. But when it comes to memory and when it comes to the interconnect, we're only doubling every 2 years, 1.7, 1.6, 1.4. That has created for us a big challenge. If we're investing, and trust me guys, we're putting a lot of billions of dollars into startups and into funds. If there is a startup that tomorrow can tell me we can work on compound semiconductors to make sure that we can improve the efficiency in compute, we're going to invest. And we can tag team with A60Z for that matter as well, right? So that's the first unlock that I want you guys to work on. Second, we need a new architectural approach to optimize for how we look at even accessing memory. There are 3 right now major archetypes. There's a memory on the chip, next to the chip, and on the side of the chip. We're working with all of them. So one company that actually spun out of Google called Grok with a Q. Jonathan Ross have done a fantastic job, language processing units. But there's a limitation. It's only good for text. It leverages SRAM, which is quite fast. That's why we're working with the likes of Qualcomm with neural processing units, how we can work with DRAM, which is memory next to the chip, and then with the NVIDIAs and the AMDs, we're working through the HBM architecture, calling on solid state storage. So first one, compound semiconductors. That's a big business opportunity that all of you should be working on today to make sure you create the next unicorn and decacorn. Memory architectures. We're overdue to pivot from the von Neumann architecture. Third unlock, interconnect. I've worked on InfiniBand back in the 90s. We're still working on InfiniBand. Photonic AI architectures are overdue. Every time we convert from optical to electrical, you guys know this best, we hit losses, there's leaks, and so forth. We need to do these unlocks. So semiconductor development, memory architectures, interconnect architectures. I'm telling you from today, these are the next $100 billion market opportunities that you guys can work on. Let's talk right now about other types of inefficiencies that we have in the system. So we've been trying to work with liquid cooling, immersion cooling, and all of these types of coolings. So you asked me before the session about how many gigawatts we're building.
Right.
So for the time being, we're building anywhere between 1.5 to 2 gigawatts worth of compute capacity. My challenge is that we want as much power to go to the GPUs. So far, the tax is 50%. So every time we build a data center, if it's one gigawatts, 100 meg will go to translation for stepping up from high voltage to low voltage. That's out of the way. Then to cooling, then to networking and storage and all of these equipments. If you can help us create the next big compute architecture to make sure that as we pump those gigawatts or megawatts, they go straight to GPUs, because this is the highest cost, What we have been able to do is, for a shell data center without the compute, is anywhere between $8 million to $12 million per megawatt. When you overlay compute, it jumps to 20 to 30 megawatts. Or sorry, 20 to 30 million dollars, depending on who you work with. If it's the Groks of the world, the Samba Nova of the world, the NVIDIAs and the AMDs. We need to make sure that I see a couple of smiles when I said Samba Nova. You guys familiar with that? So Samba Nova, let me give them some credit, helped us work with Aramco, one of the energy leaders in the world today, on making sure that we realize it's one of the real use cases of AI. Within agentic AI, $1 billion worth of savings. And the way they have done it is helped us first develop a generative AI that looks at the porosity of an oil well, how many runs we can do that, and democratize that wisdom to be able for the CEO of Aramco and the engineering team to appreciate the savings that we can do. And guys, remember, that's the second signal, or the third signal I want to talk about, which is it's all about adoption and diffusion of these technologies. I'm sorry to say that. MMLU, there's a lot of startups right now from the Silicon Valley. They could help us game the data sheet for $5 to $6 million. They were good enough in the early days to flex some muscles about how the models can be able to win at game a certain number. Right. But right now, what does it mean for GDP? What does it mean for productivity? So hardware challenges we need to work on. Secondly, how we transition into diffusion and adoption. If you're not able in this classroom to articulate to me in very simple terms how your next technological breakthrough can create for me jobs, GDP, productivity, top line, bottom line efficiency, you're not relevant to a decision maker. So I'm hard to say.
So I'm gonna go deep dive on that for a second, because when you're talking about moving GDP, the time cycles on which you need to plan on are decades, right?
Oh yeah.
But the time cycles of a compute architecture can be anywhere from 18 months to 24 months before. We had Jensen here. The Blackwells have basically essentially made a 2.5 times performance gain on the H100s just from 24 months ago. So now you've got to build 2 gigawatts of data centers, which literally nobody else has done yet. It takes 18 months to at least rack, stack, and bring that data center up. And then the useful
18 months to 36 months, depending on the site location.
Right, and what your permitting looks like in which country you're in. But in the kingdom, it's generally a little bit more accelerated than the rest of the world because of how...
We got the Grok node in 4 months.
Yeah, okay,
but that's the exception.
We call that founder mode over here. But if you're planning GDP movement on decades, but your compute, you've got to make that decision for a data center on 6 to 8 years, and the leading edge moves every 18 months. How do you break down the infrastructure planning cycle? How do you make sense of the short, medium, and long-term decisions you've got to make without basically throwing up a data center that's largely obsolete by the time it even comes online?
This is going back to history. In every technological wave, you had folks that shaped the market and people who responded to a market. And I think in today's time, you have to be agile to do a little bit of both. So you can't really deploy all of your capital by saying, I'm going to build it and the hyperscalers are all going to come.
Okay.
And then the use cases will follow. I think it's a little bit of both. And that's why in the kingdom right now, in Gen AI, generative AI, agentic AI, and physical AI, we're really pushing the needle and the envelope on 3 major use cases. As a matter of fact, the World Economic Forum have called them as one of the biggest real use cases.
Right.
So in generative AI, we had startups work on tackling sickle cell disease. For those who are not familiar, your red blood cell turns into a sickle, and it basically clogs into vessels. Unfortunately, it causes loss of limbs and lives for 20 million folks in Middle East and Africa predominantly. This specific startup called Nanopalm from Saudi Arabia, and I ran the national labs for Saudi Arabia, and he happens to be a scientist there. He said, I will take drug formulation, which typically takes for a specific, for a sickle cell disease, 10 years, to 2 to 3 years, be able to look at the different permutations and characteristics and attributes of how to design the right nanorobot with CRISPR technology, that's gene editing technology, to be able to take out that gene called sickle cell and be able to save lives. And right now, this is one of the most promising use cases of generative AI across the globe, and we take huge pride of it. A few lessons learned there. You can cut corners with generative AI, but when it comes to governance, you still need to conform to the risk-based assessment per industry. So since this is healthcare, we could not cut corners on clinical trials. You still needed to go to stage 1 for toxicity and side effects, stage 2, which is efficacy, stage 3, full approval. So even though we shrunk the time that it requires to formulate this drug from 10 years to 2 years, we still had to go through the clinical trials governance in the context of healthcare. And I think it's a very good problem statement for Stanford graduates to work on, is how we can create that balance between that risk-based assessment approach for governance versus not stifling innovation.
Got it. Okay. And so if you're, it sounds to me like one of the ways you think about managing your infrastructure build-out is you work backwards from use cases that you're excited about, like the one you just mentioned, instead of trying to plan out.
There's two more, but I'll keep that for your next question.
But no, basically, if you're working backwards from use cases and workloads, as opposed to trying to predict where the compute architecture might go to, then as long as the workloads get handled, especially the use cases that are important to the government, then you're essentially resilient to the risk of going obsolete. Is that roughly the right way to think about how you prioritize what infrastructure to invest in?
Indeed. So there's an inside-out look and an outside-in. So from an inside-out, we looked at our economy. Our economy, we're transitioning from a factor-based economy, predominantly energy, to innovation. So it was natural for us, and I'll talk about the other use cases, to deploy agentic AI for managing corrosion within a pipeline operation, managing drilling runs, and optimizing $1 billion worth of savings for Aramco.
Right.
It was also very critical for us, similar to the US, if you look at the current spend of healthcare expenditure as a percentage of GDP, the current system is not working. It's going to bankrupt a lot of economies if we don't do anything. So it was very natural for us to pick up the signal that we need to focus on healthcare.
Right.
And that's the physical AI use case, which is the world's first fully robotics heart transplant, where to do an incision and to make sure that you operate a heart transplant, typically you would need to admit a patient from 6 to 8 weeks within the ICU, and in some cases the CCU. And you need to cut about 20 to 30 centimeters, where with fully robotics leveraging AI, you're only cutting 2 to 3 centimeters, and be able with hand robotics, be able to do the heart transplant in less than 4 hours, and the patient can be out in less than 48 hours, which is remarkable. And think about what we can do to close down the gaps when it comes to heart surgeons, remote surgery, deliver some of the promises of the early days of my networking days.
So I'm going to pull on that thread a little bit. Many of the use cases you've just talked about are fairly mission critical use cases.
Oh yeah.
One of the speaker we had here last week is Guillaume Lompel, who's the chief scientist and co-founder of Mistral.
Oh yeah.
Which is a company you're familiar with. The kingdom's invested in Mistral.
Yeah, we're big on Mistral. Go Mistral.
Well, why has open source been so, my understanding is part of why Mistral has been exciting to the kingdom is because they build solutions for mission critical industries like the one you just talked about. Why has open source been the solution, or why is open source finding so much of a fit in the kinds of use cases you talked about?
My original signal. History is a great predictor of the future. You don't need a crystal ball to predict the future. Just go back in history and you'll be able to appreciate that we're competing protocols, IP at the time for networking and other protocols, and then IP prevailed, and there were some proprietary systems that still existed. But through standardization, and thank you NIST from the US, and all of your DoD certifications, IP prevailed. Similarly, I think when it comes to models, we're going to see both closed and open source models. And at one point within the industry, there will be a standardization to approach. And really, from an end user perspective, and we spoke about this last night, we're model agnostic. So whatever model helps me save lives, improve efficiency, create GDP and productivity, we will use. I remember back in the day at Cisco, we used to say, no technology religion. I should say right now, there should be a no model religion. So some folks are too attached to a specific model, and right now, models can borrow brilliantly from each other. So if we look at what DeepSeek did, they really borrowed from Mistral's mixture of experts, implementation within their Mixtral, and was able to implement it. So I think the world is going to converge to a world of many models, closed, open, small, large, and hence my coaching and guidance to the brightest folks that we have here in the room is don't be too attached to a specific approach, because the market is so agile. The change that we have seen in the past 2 years actually dwarfs the change that I have seen in my past 20 years. I don't know if you can relate to that.
It feels, there's this meme I love, which is it's a comic from Tintin where the Captain Haddock is saying, "Gosh, what a week, huh?" And Tintin says, "Captain, it's only Monday."
Oh yeah.
That's what every day feels like in infrastructure and AI right now.
Oh yeah, oh yeah. The changes that are happening, but again, it's the expectation of this room to really create the next breakthrough.
Well, speaking of this room, we've got tons of questions piling up, so we're going to switch to student questions.
I'm all yours.
Shall we take the first one?
Any questions?
Yeah. So our first question comes from Brian Wu.
Brian Wu, raise your hand. There you are.
Yeah.
Hello,
Speak
Thanks
up.
so much for taking time to talk to us today.
No, it's
I'm
an
actually more interested on your involvement with the Saudi Space Agency. So can you just talk a bit more about your vision for the Saudi space program, how you plan to collaborate with other companies and space programs, and what the future looks like?
For the recording, if you could just repeat the question.
So the question was regarding space, which is my next favorite topic. If you ask me pre-Gen AI, it used to be space, then technology. Now it's AI, then space. And I would deem that the space industry, if they want to achieve the promise of a $2 trillion industry, they must evolve into the convolution of AI and space. So for those who are not familiar with the space economy, it's split into two ends, similar to the stack that we work on in AI. You have your upstream, which is predominantly space exploration, lunar mission. Now we're talking about going into Mars. And then you have the downstream, which is the commercial applications, space communication, LEO, MEO, GEO, Earth observation, how we could make sure that we monitor the climate and make sure that we have a safe planet. And then you have navigation, which, by the way, affects 11% of the EU economy. Our own study is about 6 to 7% of our own GDP. And this is right now where our laser focus on. So Brian, for your question, the kingdom is laser focused right now on building space communication technologies. We're working with everybody, LEO, MEO, GEO, and we believe it's the intersection of these technologies that really gonna provide to you the most robust breakthrough in next generation communication. We don't believe that you should rely purely just on LEO, and GEO is too outdated to be a standalone offering. Secondly, Earth observation. So one of the use cases where AI and space have intersected in the kingdom, one of the biggest challenges that we had is random farming. So we had farmers do random farming all over the place. It affects 75% of our desertification effect, which is basically making sure that we don't have enough vegetation and green land within the kingdom. And hence we leverage geospatial data, putting it in an AI model with convolutional networks and so forth to be able to appreciate where can we nudge and pivot this random farming to be able to cut down on desertification effect, on polluting the environment, and on wasting underground water. So in 1 year with random farming, we used to consume what we needed in 1 year. we used to have 3x of that usage just because of the random farming. So we were able to save significantly, bring that leakage to down by 66%, leveraging data, AI, and space. So for us, it's very key. We're aligning and working with everybody. We're working with SpaceX. We're working with your Space 1.0, 2.0 players, the Lockheed Martins of the world, your defense system integrators, and we look forward to collaborate with you, Brian, on that.
All right, should we take the next one?
Yeah, next question is from Avi Udash.
Avi,
Avi?
want to raise your hand? There he is.
Go ahead.
All right.
How did you get the opportunity to work for the Saudi government, and what did switching from like corporate to the government role like?
The question is, how did you get the opportunity to go into public service in the government, and how did you think about making the transition?
I have to thank the Silicon Valley. His Royal Highness the Crown Prince made his first Silicon Valley tour back in 2016. And I was still working for Cisco, and it was me and John Chambers demoing to His Royal Highness how digital technologies can transform nations. And we were sharing with him our digital India experience, our digital Australia, Germany, and all of these digitalization journeys around the world. And His Royal Highness stopped us and he said, guys, I want to talk about digital Saudi. And then 3 months later, I was called into the office and His Royal Highness asked me to make a leap of faith. And it has been the biggest blessing to me because it gave me an opportunity to really deliver on my leadership impact plan. This is a plan that it took me a while. I came to this realization in 2011, where it took me a while to appreciate what was my sense of belonging and purpose in life. And it's a saying in our culture, and you guys need to do your own discovery. And it's okay if you don't have the answers right now, but you're gonna come to it at one point in your career, and you're gonna appreciate that you need to work for something bigger than life, have a sense of meaning to everything that you do, the reason why you wake up. And that saying that says this life's journey will stop unless you do three things: acquire and disseminate knowledge, build the next generation, and give back. And then when I met His Royal Highness, it hit me. It says, this is my opportunity to share my knowledge, help build a nation. And with his leadership and guidance, we went to a $135 billion digital economy, growing by 60% in 7 years. We've doubled our tech force from 150,000 to 381,000. Mind you, in the valley today, you sit around 320. So we were able to do and be part, and I'm very blessed. A lot of my colleagues are here, at Noura, Thibault, Abdullah, Salwa, all of them. I'm very fortunate that I'm blessed with a team that is much smarter than me to help me achieve this vision to His Royal Highness. But it has been the biggest blessing. My guidance to you, as much as possible, because life is about opportunities, so never turn a good opportunity, huh? But I would recommend you start in entrepreneurship, working for a big AI, big tech company, a good lab, and then you would realize at one point you want to give back to your society, to your nation. You want to help build the next generation leaders. When that comes, you will have predominantly two choices: either an NGO, and I know that all of you are part of your job and part of your giving back, and that gives me a huge sense of pride to partner with you. My dear friend, either into an NGO or a government. So that would be my guidance. So to me, it was the phase of, as I said, learn, earn, return. It was my return phase. An opportunity to give back to a kingdom, that gave back to a region. As a byproduct of the growth that we achieved in the kingdom, it took me huge pride to see the growth in Africa and the Middle East that happened with entrepreneurship. Out of the 15 unicorns that took place in that part of the world, 7 were fueled by the kingdom across the region, and then helped the world. And right now have an opportunity to team up with some of the brightest minds of the next generation to be able to change humanity with technology. Next question.
All right, yeah.
Next question.
These are good questions. Were these
getting
planted?
No, but clearly next time we should have some of them sub in for me. These are I think your answers are inspiring better questions. So we'll try to get through as many of them as we can. What's the next one?
Let's extend. I'm loving this. We'll extend.
Yeah, next question is from Antonio Alonso.
Antonio.
Where's Antonio at?
Given the immense level of investment into AI data centers by Stargate and hyperscalers and return on the invested capital will be high from this, or do you worry about overinvestment?
The question is, do you worry about overinvestment in AI?
I think the market will correct, and we just have seen a few small winters, not even a winter, a few springs, if I could call them. Similar to the old days, a lot of nations have doubled down on fiberizing the nation, building a networking kit, and so forth. But down the line, as the use cases of the proliferation of these technologies and the unit of economics have come down, they will pay off. So these infrastructure plays, by design, they're mostly developmental. They help economies thrive. I mean, there's a wonderful study by the International Telecommunication Union, the ITU, that suggests for every 10 percentage points of growth that you achieve back in the day in broadband, you see 1 to 2% growth in GDP in 2 to 4 years. Similarly, I believe this is the infrastructure that will fuel the intelligent age. What we cannot afford is sensible nations, and the Kingdom is aligning with the US beautifully on this because we have shared values that this has to be a safe, responsible technology to benefit humanity. What we cannot afford is a repeat of the failure of the digital age. Let's remember, the digital age promised us that it's going to be the biggest social equalizer and economic multiplier. But let's look at the world today. For every dollar made in the global south, and I come from the global south, 3.5 to $4 are made in the north. And we cannot say that this is going to be an exclusive cup of the few, because even my dear friend Satya did the podcast a few years ago, and he said he can't grow if the world keeps growing at 2 to 3% GDP growth. So it's even critical for innovators and entrepreneurs that the whole world is healthy and prosperous and peaceful and successful. So to me, infrastructure investments, whether in training and inference, I see them as a no regret for nations that have the following comparative advantages. If you have the energy advantage, and we do, we bring online roughly 20 gigawatts worth of renewable, we're tendering right now. We have one of the lowest price point for solar and wind. At the generation level, a cents per kilowatt hour. If you have a captive market, and the threshold, surprisingly, for SaaS, for back in the day in the internet age, for internet businesses, and for AI is 30 million. So if you have a 30 million population, what's the population of California?
I don't know. The Bay Area, we're at about, I know the San Francisco metropolitan region is 800,000, but California, it's
one of the most.
Somebody want to look us up?
Like 37-ish million?
37
there you
million.
go. So if you have 30 million-ish folks, you have the capital, you have the energy. Investing into infrastructure is a no regret. What we're seeing here today is 70% training, 30% inference. As the diffusion of this technology and the use cases come live, it's going to flip. So the question is when, not if.
So I'm going to take a bit of a detour here for you to talk about what it was. So the fact that history rhymes. So you joined Cisco in 2003.
Yeah.
Right after the dot-com crash. Right, and it wasn't.
Thank you for reminding me.
Some scars are worth drawing, battle lessons from, and I think there's one really important one you just mentioned, which is we've seen this story before.
Oh yeah.
It was very common to open up a headline in 2002 or a newspaper and see the headline that there was an overbuild out of server infrastructure.
Indeed.
A lot of fingers were pointed at Cisco, but the reality was the cost of infrastructure in that time it was bandwidth falling. Is what it was required to allow a bunch of new use cases like Google, like search. And do you see that happening again? Or do you think something different is going to happen if there is actually a glut of inference this time around?
If it wasn't for the internet build out and the economy, we would not have the intelligent age that we have today.
Right.
We would not have the quantum age. But my reservation is those general purpose technologies. If we say we can't afford for anybody to be left behind, we need, as governments, leaders, business leaders, entrepreneurs, academics, to really collaborate to deliver on this promise. If we're saying that AI is and it's as critical as a general purpose technology, as the steam engine, as electricity, we can't make this an exclusive club of the few. Things as they trend today, by 2030, The pessimist, 700 million folks will come online within the intelligent age. The optimist, a billion to 2, but that leaves what? 7 billion people behind, right? That's not acceptable. So that says by the time you hit the market and you develop your, out of 10, each one of you, 8 will be left behind and 2 will flourish. That doesn't sound to me like a general purpose technology that is supposed to deliver productivity and prosperity for all. And that's why we had a productivity challenge, by the way, for the past decades. I mean, the world economy is not growing as fast as we want it to be.
I have a follow-up question for you, which is which I think would be helpful for folks to understand, which is the concept of virtualization and digital embassies.
Oh, yeah.
Right. So if the kingdom is building out infrastructure that allows, like you're saying, equitable access to the lowest cost inference, and you've got startups, developers from around the world who want to access that, but need the policies that the compute workloads need to adhere to be local. The solution last time around in the Cisco era and the internet era was to virtualize the workloads away from where the hardware was running.
Oh, yeah.
Do you see something like that happening?
Oh, yeah, the same trend will. I mean, remember back in the day we were talking about microservices and containers.
Right.
And so, for example, X today with Twitter, if you look at your notification engine, it could be sitting in Amsterdam. If you look at your analytics system, it could be sitting here somewhere in the US. And you would optimize to where these microservices can give you the best advantage. And some of them, if they're latency sensitive, you want them to be as close as possible to your client base.
Right.
Same thing is going to happen. And that's why, in terms of, you mentioned data embassies, in terms of regulation, we're working right now with governments like the US on giving them sovereignty over their instance to make sure that US-based entrepreneurs, big AI companies, can take advantage of our energy, captive market, and capital to join hands together to deliver both training and infra services for the world.
So does that mean a workload that a startup is running from the US in a data center in the kingdom is actually adhering to, is almost like a US embassy in that data center?
Oh, yeah.
So it's adhering to policies.
And we've seen that with cloud. If you remember the safe harbor clauses, so we invoked those. So we said, similar to how goods and services are in transit in the physical world.
Right.
Sometimes if you have a truck, you don't have jurisdiction as a government to inspect that truck because it's really passing by Saudi to another nation. Similarly, we had the safe harbor clause for the cloud in which certain workloads and instances.
Right.
So for example, for a Netflix, some content might be allowed in the kingdom, some content might be allowed in Europe.
Right.
If it's serving Europe from the kingdom, it's none of our business.
Our next speaker is Matthew Prince, the CEO of Cloudflare.
Ah, there you go.
And so this is a great segue into some of the, what they've done with on the edge.
Tell him to put more CDNs in Saudi.
I'll let him know. You can stick around and tell him. All right, next question.
Yeah, next question's from Tamish.
Tamish, raise your hand.
Thank you so much for being here and for your insight.
No, thank you.
My question was in regards to smart cities. Neom is often described as a testbed for AI-driven living. What are some of the most ambitious sort of cognitive in sense of being able to sense, analyze, and adapt to the needs of residents in real time features you expect the residents of Neom to expect in the next few years? And sort of as a part 2 to that question, how does that scale to the rest of the kingdom?
The question is about Neom.
For Neom, His Royal Highness wanted to create for us a true north and a rising star to really rally the nation. If you look at any innovation problem statement, you have an incumbent that is sustaining innovation, a low-end disruptor, and a new market disruptor. Neom for us was that new market disruption to really push the society, to push the boundaries. So far, it has yielded for us big results. I mean, in terms of green hydrogen, we have 4 gigawatts worth of green hydrogen. For those who are not familiar with green hydrogen, it's your opportunity to use electrolyzers from the Red Sea, split hydrogen from oxygen, and be able to use hydrogen as fuel. And that helps us as the kingdom move from thermal energy to green photons, electrons, and hydrogen, completing the whole cycle. So it became for us a test bed for the biggest innovators around the world of how can we crack the code of the unit of economics of green hydrogen. And right now, that green hydrogen plant is actually fueling one of the soon announced with Data Vault investments, a 1.5 gigawatts shell data center, not a core, a shell to be able to host hyperscales. So surprisingly right now, NEOM for us, it's becoming the true north of how we could lead with training and inference. Look at urban design. The urban design that we live in is really built and designed for cars and not people. Look at the cities around us, even here in the US. Within NEOM right now, we're saying, no, we need to really reverse it to build it for around people. So one of the biggest things that we're trying to crack code, and this is really an innovation problem statement, is how can we build a city in which within 5 minutes you could work, live, play, and learn? And that would be fantastic. And that's why it's a 20, 30 years old problem statement, because so far, it's since the beginning of the Industrial Revolutions, about roughly 300 years ago, cities has been built for cars, not for people. And that's why we're very excited. And we look forward where we want to collaborate more with Stanford within NEOM, and we have a lot of exciting other news coming up.
Awesome. All right, next question.
Yeah, next question is from Ishan Kar.
Ishan, raise your hand. Where are you at? There.
I guess my question was kind of about making tech accessible for all, in the sense that like there's a big gap between who has access to the most cutting edge tech right now. What's kind of Saudi Arabia's plan to make that equitable for everyone?
Questions about widening access to tech.
So we made recently the partnership with Grok available to everybody around the world. It's the most cost affordable tokens that you could access globally on inference on a Grok instance. And day one, we made all of the models available, the Llamas of the world, even DeepSeek, similar to your hyperscalers, right? It was enlightening to see that DeepSeek right now is alive on all of the major hyperscalers as well, although it did not come from the US.
I think Saba, which Arthur was telling us, launched the Arabic language model that they released, which Mistral trained on Monday, was live on Grok 4 days later.
Oh yeah. Oh yeah, so Mistral is up and running.
Right.
Cohere, Llama, we're working with everybody. It's right now the most affordable. And as a matter of fact, even when we did not even make the grand announcement at Leap, which by the way, you're all invited to join us. It's one of the largest tech events. We have around more than 200,000 folks join us and roughly $13 to $14 billion worth of announcements and 2,000 startups. It's very exciting. So this is an open invitation to everybody to join us next Leap in next February of 2026. But again, Grok is available, so we're walking the talk on making inference cheap and affordable. And we have right now many nations, many startups that could not afford the price points of legacy architectures now within the kingdom, leveraging again our energy, captive market, and capital to deliver these technologies at scale.
Great. Next one.
Yeah, next question is from Shize.
Shize, where are you at?
Thank you. I guess I wanted to zoom back into the computing paradigm topic you were talking about. I feel like there's a lot of companies and a lot of research groups are working on different topics such as photonic chips. You briefly touched upon that.
Yeah.
Brain-inspired computing using some superconductors for transistors, whatever.
Yeah.
I guess are there any areas and super new paradigms that the kingdom is investing into, and what would they be, or which ones are you particularly excited for?
The question is, which new compute paradigms are you most excited about?
One paradigm that I'm personally invested in within my professional capacity, but I have a strong interest in, is in-memory computing. If you look at the von Neumann problem statement, separating execution from data and instruction set, in-memory computing can bring it all together in memory, and you could save billions and create a lot of efficiency. So if your H100 consumes, depending on the configuration and the floating point, the precision point, anywhere from 600 watts to even greater than that. If you do the same type of compute, the same amount of T-flops, it will be at least 50% less energy. And that's why in-memory computing, we're seeing right now publications, academic work, and I think you guys have a unique opportunity to create the next big thing in in-memory computing. There's right now in-memory computing and near-memory computing. So these are very exciting architectures because they really shift, it's a paradigm shift. We're stuck in the von Neumann was 1945, if my memory serves me. That's a while back. We're still working on CISC architectures, RISC architectures, x86. We all have seen, without naming names, what certain companies, because they were too religiously attached to a specific architecture, it can create bloatness and inefficiency, and it does not help anybody, including themselves and their shareholders. So in-memory computing, near-memory computing, again, we're watching that space. AI photonics, compound semiconductors, those are areas right now we are seeing them emerging from labs. But if I would correlate, we're seeing the trend between publications, prototypes, earning calls by certain startups. So there's something going on. But if something can crack the code, it's somebody like you from Stanford.
We have time for one last question.
Let's do two. Let's do two.
Two.
I love this crowd. I love this crowd.
Who's next?
Next question is from Song.
Song, raise your hand. Where are you at?
Yeah, thanks very much.
No, thank you.
Very exciting discussion.
No, thank you.
We have a bunch of like 30 PhDs and master students working on embodied AI.
Can I get all of your CVs? No, I'm just kidding.
Our question is like, what do you talk about surgery robotics and about in-memory computing, so lots of things we've already covered. Our question is like, what do you think? What kind of area are you exciting about robotics, like embodied AI?
What area of robotics are you most excited about?
So we spoke about healthcare, and I think the promise of remote surgery with AI can see light. So that's something that we're very excited about. Something else that I think the whole world is talking about, and the value pools are there, robo-taxis. So right now we're working with a lot of Stanford-based startups, the who's who, to make sure that robo-taxis can be delivered. Because if you think about it, these repetitive tasks, we're better off offloading those workforces and those workers on more high value generating segments of the economy. So robotaxi is real, and it's here to come. Robotics in healthcare is big. We're seeing it firsthand with the heart transplant story that I shared with you, and to me, it's very exciting. We're also working with a company called Intuitive Machine, going back to your space example, on building rovers for water extraction from the moon. But what we're really solving for is how we could solve these harsh environments in lunar, in the moon, but really solve them for one of the most water scarce companies across the world. So these are also very exciting opportunities for us.
All right, we're going to take one final question, because then
It has to be
we're gonna
good.
let
No, it's
Abdullah go.
Yeah, next question is from Jagit.
Jog it.
Thank you so much for being here and taking the
No, thank you.
So I really enjoyed your
Is that Liquid AI shirt?
yeah, it's from the career fair.
Ah, good company.
Yeah. I really enjoyed your take on like compound semiconductors and new memory architectures as being the next big thing. And I was wondering, what do you think is the biggest misconception about the future of agentic AI? And do you think there's too much of an emphasis of software over hardware?
The question is, what do you think about agentic AI?
Agentic AI. We have a project, and by the way, this is an open invitation. It's a public request for information. We've done it, so I can talk about it freely. We're working on an agentic AI project, how we could enhance and augment productivity for civil servants within the government of Saudi Arabia. And as a matter of fact, we believe we could create billions of productivity as a result of that. So I had the pleasure of really scanning the market. What's happening is that you have two types of players. You have your AI native players, and you have your AI enhanced. AI enhanced is those companies that used to be in B2B SaaS. So without naming names, because I don't want to promote for a lot of companies here, so they have vertical expertise in a specific domain. Let's be generic, healthcare, human resources, finance. And right now, they think because of their proprietary data, supply chain integration within their Fortune 500 companies, they could just throw it at any model and come up with an agentic AI. Some success stories at the task level, but at the workflow level and at the multi-agent level, we haven't seen a lot of results there. Then you have your native AI players, which are really presenting some really unique use cases without, again, promoting a lot of brands. So the AI native players, we're seeing them take a completely totally different approach, because a lot of people think the challenge is in the model. It's not in the model. It's in the data and the business model. And those companies, they know how to create data, cleanse data better than anybody else. So your legacy B2B SaaS players, they're making some runs, some successful task level augmentation. But I'm really excited about the AI native players that are really tackling the human in the loop problem statement, the data layer problem statement. So I'm very excited about it.
All right, well, that's a great note to end on. Thank you so much for coming.
No, thank you for the invitation.
And hopefully folks will show up to LEAP next year in the middle of finals.
Thank you. Thank you. Thank you.